For transient flow, we're really going to think about the flow equation and what it means, where we have this divergence of the flux on the left-hand side and the change in storage with time on the right-hand side. Perhaps the simplest way to think about it is water pouring into a cup with a hole in it, which is really no different than a soil buddy. So let's take a minute and look at that. This is my soil buddy. His name is Paul. I'm subjecting my soil buddy to constant influx here, and you can see that it has established a constant head so that the energy at the outflow through the sponge is exactly sufficient to allow that amount of flow through the sponge. If I increase the flow rate, then I see that the soil buddy has to respond, slowly increasing the water level until again the head drop across the sponge is sufficient to match this new inflow. What's interesting is to think of what's happening during that transition period. We have more flow coming in than we have going out, so we have a divergence of the flux, and that is related to an increase in the water level or a change in storage. This is another example where I tried to embed some quizzes. The times on these is a little long, so you might want to have your fast forward finger ready. The question here is, if you're looking at that soil buddy, how can you tell that there's a change in storage with time? So what is the obvious visual indication that it's a transient process? For those of you who are still with me, it is the change in water level, right? That is a change in storage in that entire system. Now it's a little bit tricky here because it depends on what you're calling your system. If your boundary condition is at the top of the sponge, you really can't see that change in storage. It's an expansion of the sponge. But taking the whole soil buddy as your system, you're seeing that change in storage as the water level change. Here again, it shouldn't take you the full 60 seconds to answer this. You should be able to answer essentially right away. But I'm going to wait a couple of seconds and then I'll give you the answer, and you can then scoot ahead in the video and see that written down. So this is an important concept of thinking about what the boundary of your domain is and what represents the rest of the universe. So if we think of the top boundary as being the top of the sponge and the bottom as being the bottom of the sponge, then nothing is changing on the bottom boundary. It's defined as the head or the energy level of the water at that boundary. The top boundary is having a change in the hydraulic head through time, and that's indicated by that slow rise in the water level within the soil buddy body. So really the best way to define that would be a time-varying type 1 boundary condition. This does have some interesting implications. That system of the sponge is so small that there's really no change in storage within the sponge through time. So really what you're seeing is the change in storage within the soil buddy body, and that means that the boundary condition at the top of the sponge is slowly changing with time, but there isn't really any significant transient response within the soil buddy. It's a little bit complicated. Think about it a few times and wrap your head around it. Okay, you're going to have to believe me or look very carefully at the video, but the water level in the body of the soil buddy, it rises fairly quickly at first, and then it rises more and more slowly through time. And this is because you're supplying the soil buddy itself with a constant flux of water. You're slowly increasing the gradient across the sponge. So with time, the flow out of the soil buddy body through the sponge is increasing. So as that increases, the difference between the flow in and the flow out gets smaller. So the addition to storage with time gets less with each given time step. So in other words, the water level will rise more slowly with time as the outflow approaches the inflow. So this is similar to what you would see if you actually applied a type 2 boundary condition right to the top of the sponge. You would see that at first you have a big change in storage, and then through time that difference of inflow and outflow gets smaller, and so the change in storage with time gets smaller as well. Now's a good time to fast forward. If you're still watching, I assume that you're one of those people who stays to the end of the movie to watch for the best boy and gaffer names, and perhaps to see what locations provided tax breaks for the movie's filming. This was entirely filmed within the territorial area of Arizona, and we received no tax breaks. We did not have a best boy. Actually, that's not true. Molson, come here. Who's a good boy? Who's a good boy?